GIS or perhaps ArcGIS, I'm not quite sure how specialized you are. And so SB Harish, known as, or Harish, known as Harish.
Yeah, it's like Madonna, just like.
Yeah, I know. I don't even know what SB actually stands for.
Subgame perfect.
Subgame perfect. That's pretty good.
Yeah.
Your parents are very clever.
Yeah. I know.
Okay. And as always, you know, clarifying questions and such. Go for an hour or so it's not going on till 8 o'clock.
Okay.
And you have some stuff for them to get or something?
Yes, I'll come to that. All right. Thanks everyone for coming. Thanks to Neil for organizing this spring workshop series. I'm Harish, and today we'll be looking at GIS using a software called ArcGIS. There are both advantages as well as limitations to using this approach. The main advantage of using ArcGIS is that it lets you create really pretty maps in a very short span of time. It has a number of inbuilt tools that you can use, and it has got fairly robust support from both ESRI, the company that sells ArcGIS, as well as other online forums. The biggest disadvantage about using ArcGIS is that it's not free. And one of the things is that it's incredibly expensive. That being said, NYU has like a university-wide license for ArcGIS. The lab computers in front of you have ArcGIS installed on them, the latest version. If you need ArcGIS on your laptop, you can get a license from the NYU library and use it. So as long as you're affiliated with NYU in some way, shape, or form, there's really no reason why you cannot or should not use the software. So irrespective of whether you plan to learn GIS without using any software, it's possible to do so, or decide to use some other software. You can use Python, you can use R. Some of the concepts, are the same. So hopefully that part of this workshop will be useful to you in case you choose some other approach in the future. One last point I want to make before we start is 2 hours is way too less to learn GIS in its entirety. So we've had to pick and choose certain things to talk and certain things not to. So if I do some hand waving, it'll primarily be in the interest of sticking to the allocated time. I'm happy to stay back after 8 to talk more and answer your questions if you have any to the best ability that I can. So if any questions before we begin? All right. So this is the agenda for today.
Just to be clear, so you're not going to talk about statistical analysis?
No.
Which we'll have another workshop on.
Yeah.
Yeah, I know the answer to this question.
Yes, that's right. So I won't be talking about statistics.
About how to get geographical data.
And how to create maps and how to do some basic spatial analysis. So the agenda for today is I think we're going to have a break at the end of the hour or so. So in the first hour, I hope to cover these 4 things, which are basically basic GIS concepts, give you an introduction to the software, and also discuss this incredibly important but excruciatingly painful topic called coordinates and projections. And hopefully we'll be able to get through all of that in the first hour. After we come back from the break, we'll probably do more fun stuff. So we'll look at some basic GIS analysis. We'll create a thematic map, which is like a map that you will typically create and put in one in a presentation or a paper. And time permitting, we'll look at how to take the GIS analysis that you have and export it out of the software and put it together with a data set, which then you can use in Stata or R and run your regressions. So throughout the next 2 hours, we're going to be moving back and forth between GIS concepts and ArcGIS. Hopefully you'll find that useful. But like I said, if you choose to use some other software, just pick up on the concepts and you should be fine. So before we start, there is some data that I've created for you guys to use. So for those of you in front of computers, once you log in, you should be able to access data on the iDrive. There should be a folder called ArcGIS_workshop_SP13. What I need you to do is to copy the entire folder and its contents onto your H drive. So please do not use the files on the iDrive. So the iDrive basically should contain all the master files, and the H drive is what you're going to use for this workshop. So perhaps we can take a moment while you guys do that. And if any of you have problems, just put up your hand and I can try to assist. So these are the files that you should be able to see in that folder. So So just to repeat again, you should be able to navigate to the iDrive. There should be a ArcGIS folder there. I need you to copy and paste that entire folder onto your H drive, which is your home drive. All right, let's move on then. So very first step is to understand what exactly is GIS. So GIS stands for Geographic Information System. It has primarily one goal, which is to display geographic information on a map. And this is a very rudimentary example of one such spatial information that you can provide. So this is basically the population of continental United States between, say, the ages 30 to 34. So any kind of data that you want to represent spatially on a map, that is the one primary goal of GIS. So what are the kind of information that GIS actually stores? So there are two kinds of information. One we'll call features. So what are features? Features are, simply put, real-world objects that you put on a map. These objects can be natural, like mountains, rivers, lakes, or they can be more man-made. And those are the ones that we're actually going to use in this workshop. So for instance, this is a map of all airports in the United States. This is a map of all railroads in continental United States. And this is a map of all counties in the US. And these are the kind of information that GIS stores and needs in order to display the map to you visually. The second type of information that GIS stores is called attributes. What are attributes? Attributes basically describe the features in a GIS. So for instance, remember we had the map about US counties. If the US county is a feature, an attribute for such a feature might be county name. So as you can see here on the table on the right, you can have the name of the county as an attribute for the different counties within the country. Another possible example is county size. And yet another would be, say, the vote share of the Democratic Party in a particular county. So these are all attributes of a particular feature. Any questions so far? So remember, we have spoken about two things so far. One is features, one is attributes. And we are going to keep coming back to these over and over again in the next hour or so. The third thing is, what exactly does GIS do? So given the need to create visually representative data, the need to store information either as features or attributes, what does GIS do? It creates a database that basically links features with attributes. This basically helps you draw really pretty maps and also lets you edit and analyze geographic data. Think about how this is pretty different from, say, using paper maps. So if you had a paper map, everything is static. The advantage that GIS gives you is that it is dynamic to the extent that you can zoom in, zoom out, conduct all these analysis, take out that analysis for some other purpose that you may need. So in summary, what does GIS do? It gives you visualization. it lets you display maps, whether you want to display them on paper, so possibly like in a journal article, or on a computer, say for instance, perhaps for a presentation. These maps can either be in color or in grayscale. There is a database, like I mentioned, that GIS adheres to. And this database allows you to import geographic data from various sources. And I'm going to discuss some of them as we go along. And importantly, it lets you convert this data into information that you want your reader to interpret when they actually look at these maps. And lastly, it lets you do, I think, fairly good spatial analysis, maybe not spatial statistics, but at least decent spatial analysis, which lets you find areas of the map based on a certain criterion. So for instance, if you wanted to know which cities in the US are within 100 miles of the Atlantic coast, GIS can tell you. If you wanted to know which villages are within a 50-mile radius of a epicenter of an earthquake, GIS can tell you. And ArcGIS is basically just the software that we will use like a front end to possibly get a lot of this data. And we'll actually do one simple example in the second half after the break, where we actually try to find some of this. Any questions? Okay. And just for Yulia, so if you log into your computer and you navigate to the iDrive, there's a folder called ArcGIS, which basically uses some of the data that we will use today. I need you to just copy that folder and paste it to your H home drive. Okay, cool. So we now delve in a little more detail into GIS concepts. So we are going to learn 3 of them now. One is called features, one is called layers, and the third are called scales. So what are features? Features, remember, like I mentioned before, are basically real-world objects on a map. But features come with 4 components. A feature needs to have a shape. What do I mean by shape? It can either be a point. So think about the map that I showed you about, airports in the US. That uses a feature which uses a point as a shape. You can think about a feature having a shape as that of a line. So for instance, the map that I showed you about railroads in the US, that uses a line as a shape. And lastly, you can have polygons. So the map that I showed you about US counties, all those small counties, each county is in a shape of a polygon, and that would also be a shape. So remember, features have 4 components. We're discussing the first one, namely shape. And shape can either be a point, a line, or a polygon. The second thing that a feature has is location. So as with any map, you need to know where exactly this particular feature actually comes up on the screen. So you need some kind of a reference point, and that typically is a latitude and longitude. And we will discuss more about latitudes and longitudes when we discuss coordinates and projections. Yes, please.
Sorry, you're probably going to get into this, but just like top of my head. So when we have like a feature that's in the shape of a polygon, is its location based on like the center of the polygon, or is it each like line? Or?
So typically what you can calculate is the centroid of the polygon, the latitude and longitude of the center, and the polygon has its shape, which then basically falls around that centroid. So a feature comes with a symbol. A symbol can either be a simple shape, a color, an outline, a pattern, or any combination of the above. What do I mean? So think about that airport map that I showed you earlier. How did I depict that airport map? It was in terms of dots. But I need not have chosen dots. I could have, for instance, chosen a picture of a small aeroplane, for instance. Right? So remember, there's a distinction between the shape of a feature and the symbol that is used to represent that feature. So that distinction is important to make, although typically we always use the same together. And lastly, the 4th component of a feature are attributes. And this is basically information to describe features. And to give you another example of attributes, think about a polygon, which is like a US state. And what could be possible attributes of a US state? For instance, you can have the state name as a possible attribute. You could have the state capital as a possible attribute. And you could have the state population as a possible attribute. So all these different attributes all come under features. So the second thing we're going to learn are layers. What are layers? Layers are basically collection of features. So remember, we've spoken of features so far. Layers are basically collections of features, but not just any collection of features. There's a very specific condition that these features need to have the same shape and the same attributes. What do I mean? It's possible to best do this through an example. So think of the example that I showed you earlier, which is a map of, say, some distribution of US population, right? This is a map that has polygon as its feature. It has an attribute, namely that of population, and it has this latitude and longitude coordinates such that it looks in the shape of the US map. And think about the other map that I showed you, which is that of airports. What layers lets you do is to actually put the two together like that. So you can actually take different things and put them on one on top of another, and layers basically lets you do that. So you just layer different maps one on top of another as you wish. And you can do analysis from one layer through another layer. And we'll do an example to show you this. The third concept we learned today are scales. What are scales? We all know how scales are typically represented on paper maps. So for instance, if I say a scale is 1:12,000, that means the real world object is 12,000 times the object on your map. And that's the same with GIS maps. And there's another type of scale which represents distance. So when I say 1 inch is equivalent to 5 miles, that means you will basically say that every inch on your map corresponds to 5 miles in the real world. What GIS lets you do, which is not possible with paper maps, is to zoom in and out and actually see more information than you might otherwise see. What does this mean? It means you can actually change the scale of a map. So for instance, look at this US map again, which has the list of airports as represented as a dot. Now look at Florida in particular right there. You don't know how many airports are actually there because the scale that you're using currently does not let you actually count or even find out the name. But what GIS lets you do is you can zoom in and you can label each of these dots so that you can actually count as well as see the names of these different airports. And we're going to do an example with this also to give you an idea about how this is done using the software. Any questions? All right. So remember, we have done 3 GIS concepts so far. We've done features, we've done layers, and we've done scales. Yes?
Is there any way to sort of nest features in each other? And for instance, that you would have like states and then counties in them or something, any way to...
Sure. That it's totally possible. Yeah. So for instance, this would be nesting airports with states. And I can similarly nest counties and states also.
But that, I mean, that shows up on the map now, but does it in some way also show up in the data that...
Sure.
Okay.
Yeah. You can combine the two together at whatever level you want. All right. So we're going to move on to data storage types. So there are 2 types of data that is stored in GIS. One is called vector data, and another is called raster data. What is vector data? Vector data is pretty much what we've been looking at all this while. So for instance, vector data involves shapes and coordinates. So what kind of shapes does GIS deal with? Remember, we deal with points. And what do you need for points? You basically need one pair of coordinates to depict a point. And similarly, we deal with lines. And what do you need for lines? You basically need 2 or more coordinates for a line. And if you have polygons, you need 3 or more coordinates, and you also need them to be closed. And what do I mean by closed? Just that the coordinate of the first and the last are basically the same. So vector data, everything that we've seen so far, whether it is cities, airports, rivers, roads, states, counties, you take your pick, these are all vector data. Why? Because they all have shapes, features, they all have coordinates as given in this slide. What is the other type of data that GIS has? It's called raster data. Now raster data is very interesting. So for instance, raster data gives you continuous data. So this is actually a satellite map of the Hawaiian Islands. Why did I choose Hawaiian Islands and not the US map? Because satellite data of the US map is about 1.2 gig, and I didn't want to do that. The Hawaiian Islands are much easier. But essentially this is continuous data. So one thing I want you to kind of remember and be cognizant of is that maps, like statistics, can say what you want them to say. So for instance, if you use vector data, that means if you use shapes like polygons, lines, or points and coordinates, you cannot make a claim that your data is continuous. To make a claim that your data is continuous in some shape or form, you need data like this, which is like satellite maps. And you can get tons on those. Yes?
So it's still pixels, right?
It is, so I'll come to that, about how these are stored. So this is how raster data is stored in GIS. So they're actually stored as cells. So slightly bigger than pixels, but really, really small cells. What does it mean? That each cell has the same size, and each cell has a value, and that value can either be a quantity. So for instance, if you're talking about elevation, right, as a raster map, it could be the height above sea level at that particular cell, or it could be a code, right? So you can compress what your elevation into different categories and use a code, for instance. And every raster has an origin. So for instance, in a cell like this, which is how this is stored, their origin is probably somewhere there, which allows every single raster cell to have a very unique position with respect to this origin. We won't be dealing with raster data in this workshop, but if you want to talk more, I'm happy to talk about it after. But just to give you an idea, there are 2 types of data that GIS uses. One is vector data, and the second is raster data. And you use which one depending on what your needs are for this. And I'll show you an illustration at the end, which hopefully will put all of this together. The next thing I want to talk is a geodatabase. So what is a geodatabase? A geodatabase is basically GIS data that is stored in a database. The official definition will be like it's a collection of geographic data sets, real-world object definitions, and relationships. What does geodatabase consist of? They consist of feature classes. What is feature class? A feature class is a digital collection of features with the same shape and attributes. So think about this. How doesn't this seem really similar to layers? Because how did we define layers? We said layers were also basically just a set of features which have the same shape and a same set of attributes. So how is this very different? Well, the difference is the geodatabase basically is just a database. That's it. It's at the back end of GIS. The front end of GIS are the layers. So layers are nothing but the visual representation of the feature class. And how is data stored in these geodatabases? So if you have vector data, that means if you have simple things like states or counties and county names, all the counties will be rows in a table. All the attributes, which are like county name, county population, county area, so on and so forth, will be columns. That's how the data is stored within GIS. Raster data can also be stored within GIS. And how is raster data stored? Just like how we discussed in the previous slide, which is in the form of like cells with quantities in them. So now that we've discussed a bunch of stuff, we've discussed basic GIS concepts like features, layers, and scales. We've discussed two forms of data that GIS typically uses, vector data and raster data. And we've looked at the database that actually is used to store all of this together. Now this is an illustration. This obviously is not something that I did. It's easy to get off Google someplace, which gives you a nice illustration about how to put all of this together. So if you start right at the top, so think about that layer. That layer basically has a feature class which uses a point shape. So for instance, that will have things like landmarks and trees. The next layer below that will be lines, which will typically be things like streets, rivers, or streams. The layer below that will be polygons, which will be, say, counties, or in this case, land parcels or buildings. The layer below that, which we have not discussed in detail, which is called topography, but essentially topography can either be pushed here or pushed here, depending on whether your data is discrete or continuous. So remember, discrete data is vector data. Continuous data is raster data. And you can go one level further, which is raster imagery, and look at satellite pictures and historic photos. And when you put all of this together, like you wanted one on top of another, you can get as close to the real world as you can. Yes?
So in terms of where the data is stored, do we have different data sets for each layer, or is it all in one data set?
So I wouldn't use the word data set. So what I would basically say is that all of this can be stored in one geodatabase. And each thing that you see there are basically layers. So the landmarks and trees will be a layer each. Streets, rivers, and streams will be a layer each, so on and so forth. And you can actually use a software like ArcGIS to visually put this layer on top of that layer, and those two layers on top of this layer, so on and so forth, such that at the end you finally see as realistic a picture as possible. Although in most cases you may not need that, right? So think about each one of these as layers, and think about each one of these, if they have discrete data, that means they are vector data. If they have continuous data, like rasters, then you'll treat them as raster data. Is that okay? Okay. So we'll move to the software. So hopefully we've discussed some basic concepts of GIS, and hopefully now we'll see how it actually plays out in the software. So ArcGIS, and the part that we will be looking of ArcGIS is called ArcGIS Desktop. So one of the key things that we'll be using in this workshop, and for all practical purposes, what you will use when you use the software for most of the stuff we do, is called ArcMap. So what is ArcMap? It is basically an interface which is used to display, edit, and make queries of your maps. Another component of ArcGIS Desktop is called ArcGIS Catalog. What does the catalog do? It's basically a data management application. It basically puts together all the different components of, say, a geodatabase for you in a nice side window, which you can then drag and drop into your ArcMap. Arc Catalog is something that we won't do this today. An Arc Catalog is something that is useful, but not that useful. I use it rarely, though. So ArcMap is something that what we're really going to use, right? The third component of Arc Desktop is an Arc Toolbox. What is an Arc Toolbox? It's basically a simple toolbox that has a bunch of tools. These are built-in tools that you can use through simple wizards to actually perform basic and fairly advanced GIS analysis. And this is a picture of how ArcGIS will give you the different tools. I will demo one tool today to give you an idea about how these work. And there's incredible levels of help and assistance that's available in case you wish to use some of the other tools as you go along. And lastly, there's a search component to ArcGIS Desktop. What does search do? It lets you, search for maps. Now, it lets you search the repositories from all over the world to actually look for maps, and it'll let you actually drag and drop the map directly from the search window into ArcMap for you to use. Obviously, copyright and everything you will have to take care, but this is something that they use. We won't be going through the search, right? So a lot of the data that we're going to use today I've already given to you, so this is something that you can use if you really need to find a map and you can't find it. Any questions? All right. This is a picture of ArcMap. So what I'd like you to do is start ArcMap on your computers. So if you start ArcMap, this is how it should look like. So if you can't find ArcMap on the lab computer, just type it in the search window. And once you start up, it'll ask you for a dialog box about which map you want to open. Just hit cancel. And once you hit cancel, this is what you're going to come with. So this is the main window that we're going to use today. And again, for all practical purposes, the main window that you will use when you use ArcGIS. So a couple of things. The search component that I mentioned is over here. So if you ever wish to use it, you can just click it. Something will pop up for you to use. The catalog is also there. This is ArcMap in general. And if you click on the geoprocessing menu and you hit Arc Toolbox, that will show you the fourth component that we discussed. It takes a while to load the first time you do it, but after that it's fairly fast. So this is the Arc Toolbox that you can use. So you can find that under the geoprocessing menu and under Arc Toolbox, right? So these are the four components about ArcGIS Desktop. All right. So what does this map look like, and what are its different components? So this is ArcMap, like how we saw it, but it has a map on it. So a couple of things. Right on top, you'll see the main menu, followed by some basic toolbars that are provided by the software. You will also see a bunch of title bars and a layout bar, which is the standard stuff that you will see. The important things to keep in mind is what you see on the left is basically a table of contents place where you will see the different layers that you're going to work on a map. And this is something that we will add a few layers for you to get a sense of how it looks like. This thing which you see on the right is the data frame, which is where you're actually going to do all your editing and analysis of your maps. There are two buttons right here. We are right now in the data view tab, which opens by default. The icon right next to that is the layout view tab, which actually lets you print or display your maps in, say, a pretty manner. We will actually use this after the break when we actually create thematic maps. But for now, just remember that we are in the data view tab where you do all your editing and analysis. You only use the layout view tab to move your map around to make sure the sizes and the scales and the layouts are right, and then you can print and publish your maps. And there's a status bar, which I never use. So there you go. Any questions? All right. So in ArcMap, this is what I want you to do, assuming you have ArcMap open on your lab computers. So in ArcMap, I want you to create folder connections. How do you create folder connections? I want you to click Add Data. So how do you click Add Data? If you go to ArcGIS, this plus sign right here, so where my mouse is, this is Add Data. So once you click Add Data, I want you to click on this button right here, which says Connect to Folder. Right? What does this do? This lets you create a virtual connection between your ArcGIS and any folder that you have on your computer. So remember the folder where you actually copied out the data from the I drive to your H drive? I want you to create a connection to that folder. So for instance, I've created a connection to, never mind. I've created a connection which brings me directly here to wherever this data is stored in my hard disk. So if all of you all can do that, that'll make life a lot simpler for you as we go along. So I want you to create a folder connection. So click on connect to folder and it'll ask you for where you want to create the folder. I want you to navigate to your H drive in the list of drives and click ArcGIS Workshop SP13, I think. And then you should be able to see all the files like how I see here. You should be able to see all the files. You may not be able to see all these files in your list. For instance, all these .lyr files are not something that you will see. What you will be able to see are the .shp files in this window. I hope that's okay. If you have trouble, I suggest you try checking with your neighbor to try to see whether you can do it. But again, just to, at the risk of berating the point, please make sure you copy the files from the I drive to your H drive before you do this. Please do not use the files directly in the I drive. All right. So, assuming you guys have created the folder connections, this is the part which is important, which is that the maps are stored as shapefiles. Now, what are shapefiles? Shapefiles are basically simple, non-topological format for storing geometric location and attribute information of geographic features. This is a very complicated way of basically saying shapefiles are basically files that show you vector data, right? Remember, what is vector data? Vector data is discrete data, and you will have these different files to show you different types of vector data, and all of them are stored as shapefiles, .shp files. And you will primarily use them for points, lines, or polygons. So right now, in ArcGIS, we have a bunch of shapefiles. So the one I want you to pick is called US 2010 Census by State. And if you add that shapefile, you should see something like this. Okay, so let me do that again. Yeah. You should see something like this. Possibly you will see a color, right? Or possibly you'll see something like this. I prefer the white, but in order to change that, so one of the things I want to point out, so in your table of contents, what we've just basically done is by adding a shapefile is that we've created a layer. It creates a particular layer over here given by the name that you've assigned to that layer. There is a small box underneath here. This is basically going to control all the color of that particular map. So if you double click that, you will get another window and you can choose hollow. If you choose hollow, what happens is you're going to end up with a map like this. A pure, simple tabula rasa map of US states, right? Any questions so far? All right. So, okay. So this is what I want you to do next. After you've added the US 2010 Census by State shapefile, I want you to add the US airports shapefile, right? So if you go back to ArcGIS, go back to this icon right here on top, click Add Data, and it should automatically go back to the folder which you created as part of your folder connection. I want you to pick US airports. So you will be picking this one, usairports.shp. And if you add, this is what you should see. The two things must align themselves over one another such that you have the one layer with US states and another layer with all the airports. Did you have a question?
Yeah, so they don't have labels now, right?
The airports? Not yet. We'll soon look at labels. Yes. So this is something that I showed you earlier on a slide, but this is hopefully something that will become, clearer to you now that you're actually doing it. So this is how you can put one particular map over another. So what else can you do? So these are the 3 things that I'd like you to do, and if you just follow what I'm doing, hopefully it'll be simple enough. So one thing I want you to do is to zoom in and zoom out of this map. So for instance, in ArcGIS, I want you to click on the zoom button, which is right here on the left, top left, right here. Once you click on it, your mouse changes to a plus sign that you're going to zoom in. You can zoom in to any part of the map. So if you zoom in to this part of the map, this is what you're going to get. How do you go back? I want you to look at these 2 arrows right here. These 2 arrows will show you how to go back and forth as far as zooming is concerned. So if I want to go back to where I started, I hit this and then I come back here. So remember, this is one of the big advantages of using GIS is that it lets you change the scale, move in and out, determine which scale you actually want to use for your analysis before you actually do so. And we go back here.
So suppose I wanted to map only Florida without those ugly overlaps of Georgia.
Yes.
Do I need a different layer, a different?
No. So it requires a slightly tricky notion, which I can show you during the break.
Okay.
Yeah. It's almost like a workaround, but yes, it's fairly simple to create that. So the next thing I'd like you to do is to click on this particular icon on top, which is called Identify. So you see this blue thing here with the eye on it. So I want you to click on that and click on any part of the map. So if you click in the white space of your map, right, what it will do is it will pop up a window and show you attributes associated with that polygon. So for instance, it will tell you that the shape is a polygon. It tells you that the name of the state that I just clicked on is Montana. It tells you a whole bunch of other attributes, which are actually population variables from the census, and they're all stored here. It tells you the length of the polygon, like the perimeter, and it also tells you the area of the polygon. So these are all attributes associated with Montana. And we got that by just basically clicking on this button right here and clicking anywhere in the white space. You can also do the same and click on one of the dots. So for instance, if I click on this dot, it'll actually tell me that it's an airport. And it'll tell me an airport, it'll tell me the airport name, it'll tell me the city, and it'll tell me that's in Colorado. So this identify tool basically helps you look at a map and look if you want to find out more information about something specific on some part of the map. This will tell you that information immediately. Yes?
What if you had 2 perfectly overlapping layers, like you had the maps of the counties and the states? How would you decide?
Which ones to use? I don't know. But my sense is the order in which you loaded it into here would be the one that matters. Yeah. That would be my educated guess. So any questions? Any other questions? All right. Now the next thing what I want you to do is to basically click on this button right here, which is the binoculars, which is a find button. I want you to click on find, and it takes a little while to open, but essentially what it lets you do is it lets you pick a layer. So I'm going to pick a layer called the one that we picked, US airports. You should also be able to do so. And under the find button, I'm going to look for Kennedy. Basically, I want to find John F. Kennedy Airport, because let's say I don't know where it is on the US map. And if you hit find, see what happens. You will come to Kennedy Airport right here. It finds you Kennedy right away. And do you see what happened just now? All you need to do is to hit this search result, and then there is that dot right there which will tell you exactly where it is. Right? So like that and like that. So if you want to find out where a particular feature, you only know the name, but you don't know where exactly it is on the map. This will help you find that really easy.
Does it only look for names or also any kind of attributes?
So you can look for any attribute that is stored in your layers, which is what I'm coming to next. So for instance, remember there are two layers that we have here currently loaded onto ArcMap. One is the US Census by state, and one is US airports. So if you right-click US Census by states, and you choose Open Attribute Table, what you'll see is the database that I told you earlier. Remember, this is all vector data, and how is vector data stored? It is stored in rows, which are the features, columns, which are the attributes. So essentially, each row here represents each state in the US. This gives you the name of the state. All these DP variables are basically population based on different age cohorts. And at the very end, you should be able to see the area and the perimeter that we saw earlier, right there. You can export this data into Stata, for instance. If you're more comfortable looking at stuff there, you can take it right from this attribute table, take it out as a text file, import it into Stata or R, and use it as you wish. Right. Look at the attribute table of the airport similarly. Here, each row corresponds to each dot, which is an airport. It also has the name of the airport, which is right here. It also has an attribute called city, which is right here. It also has a state code, which is right here, and so on and so forth. And you can obviously imagine a lot more things like elevation, latitude, longitude, so on and so forth for the airports. Adam, did you have a question?
No.
Okay. So this is about ArcMap. So if that basically should give you a taste of how it is to use basic vector data and try to use some basic things surrounding how to identify features, how to find a particular feature, how to zoom in, zoom out, how to look at data that is stored behind these maps, how they are stored as layers, how to basically, look at some of your data and play around. That's the whole point of this initial exercise. We'll move on to this slightly, yes, please.
So, the census by state data does not have a latitude and the longitude column.
It doesn't. But you can calculate that.
So how do we know how to overlap them? How does it overlap them then?
Because the latitudes and longitudes of the polygons are stored inside. It just doesn't show up on the attribute table. So all polygons have coordinates associated with them. It's just that we don't actually see what the latitude and longitude is of the centroid of the polygon when you open the attribute table, but there is a built-in feature that will let you calculate that.
But the information is in there.
Information is in there.